Assalamu alaikum. Thank you for giving me the opportunity to present my MS research proposal. My name is Shoriful Islam, MS student in the Department of Farm Structure and Environmental Engineering. Today, I will present my proposed research titled Development of FRC Paving Blocks using Lathe-Waste Steel Fibers for Walkway and Farmstead Construction, a machine learning based mixed design. My supervisor is Professor Dr. Zainul Abidin sir. Now, what is the background of my study? Bangladesh is rapidly urbanizing, which has increased the demand for durable and cost-effective walkways and farmstead pavements, especially in public areas and agricultural farmstead. However, traditional concrete paving blocks face several limitations such as frequent cracking, insufficient strength, a high maintenance cost, and a limited sustainability. At the same time, lathe machine workshops all over the Bangladesh generate a large amount of steel scrap waste, which remains unused and contributes to environmental pollution. In this study, I aim to use this Lathe-Waste steel fiber to produce fiber reinforced concrete and to produce the paving block from these concretes. Additionally, I will introduce a machine learning approach to optimize the flexural strength and reduce the need for experimental trials. Introduction of the study. Fiber reinforcement plays a major role in improving mechanical properties, especially crack resistance, impact strength, and flexural behavior. This is crucial for paving blocks, which often fail due to cracking. Steel fibers are known for improving durability, toughness, and resistance to impact and cracking. Lathe-Waste steel fiber are locally available, have unique twisted shape, and are cost effective. Using them not only strengthen the concrete but also helps in recycle the industrial waste. This why Lathe-Waste steel scrap is used. Therefore, the Lathe-Waste steel fibers have a strong potential to be used in reinforcement in concrete paving blocks. Now, I would like to address the research problem and the questions. Conventional paving blocks frequently develops cracks and fail early. There is also inefficient use of locally available materials, and industrial waste remain underutilized. However, existing concrete mix design rely solely on experimental trial and error methods, which requires a lot of time. The key research questions are: what is the effect of Lathe-Waste steel fiber on the mechanical properties of concrete? What is the optimal fiber percentage for brick chips concrete? And can machine learning models accurately predict the flexural strength for mixed design optimization? Here is the objective of the study. Based on this question previously discussed, my study has three major objectives: to evaluate the mechanical properties of fiber reinforced concrete using different percentage of Lathe-Waste steel fiber, to develop machine learning models such as artificial neural network, support vector machines, Gaussian process regression, and random forest to predict the flexural strength and optimize mix proportions, to design and develop paving blocks using the optimized ML-based mix, and to evaluate their performance and cost effectiveness for walkways and farmstead applications. Here is an overview of the experimental methodology. First of all, the materials like cement, sand, brick chips, and Lathe-Waste steel fibers will be collected and tested in the concrete laboratory following ASTM standards. I will use a 1:2:4 mix ratio with a water cement ratio of 0.45. The fiber percentage will be 0.5, 1, 1.5, 2, and 2.5% by total. Concrete cylinders and beams will be cast and cured for 7 and 28 days. Then tests such as slump and compressive strength, split tensile strength, and flexural strength will be conducted. All these experimental results will form the database for machine learning models development. This slide summarizes all the ASTM standards that will be followed. For cement, I will perform consistency, setting time, fineness, and compressive strength test. For fine and coarse aggregate, I will measure fineness modules, specific gravity, water absorption, bulk density, and abrasion resistance. Lathe-Waste fibers will be measured for length, diameter, and aspect ratio. Fresh concrete will be tested for workability using the slump test, and hardened concrete will be tested for compressive, split tensile, and flexural strength. This systematic test ensures that all the experimental database is reliable for machine learning purpose. This slide shows the machine learning architecture. You can see the input and the output parameters of the models and the hidden layers. The hidden layers is not fixed. Now here is the model. You can see in the previous slide I say that the hidden layer is not fixed. That's why we are going to use the hyperparameter tuning. Now after collecting all the experimental data, I will pre-process the data set and divide it into training, validation, and test sets in a 70:15:15 ratio. The input feature will be include the fiber content, material properties, curing and mix characteristics, which I have already showed in the previous slide. The target output will be the flexural strength, because flexural performance is the most important factor for FRC in the paving blocks failure. Multiple models like artificial neural network, support vector machine, Gaussian process regression, random forest will be trained and compared. Also I use 5-fold cross validation will be used to reduce the overfitting and increasing the reliability. After training the model, I will evaluate them using the performance metrics. You can see like coefficient of determination, root mean square error, and mean absolute error. The best performing model will be selected as the final predictive system. This model will then be used to predict flexural strength and intermediate fiber percentage. For example, 0.75 or 1.25 or 1.35, as you can see, whatever you want, which are not physically tested in the laboratory, and it will predict this strength by using this model. In this way, machine learning will significantly reduce the number of trials and saving both time and cost. This is the Gantt chart showing the 12 months work plan. The first few months will focus on literature review, material collection, and testing. Next, I will cast and test the concrete specimen. Then I will move on the machine learning models development and mix optimization. Finally, I will cast the optimized paving blocks, perform cost analysis, and prepare the final thesis report. The timeline is aligned with the MS program, of course. The expected outcomes of this study are a clear understanding of the how lathe fiber influence the mechanical properties of concrete, a trained machine learning models for predictive optimal mix proportion, fiber reinforced paving blocks developed using ML optimized mixes, offering improved strength and reduced cost for walkway and farmstead use. Overall, this research will contribute both scientifically and practically by promoting local waste utilization and generating sustainable pavement solutions. Like all research work, this study has some limitation. The fiber aspect ratio is fixed at 25:30, and the geometric are not be included. Machine learning models will be trained on a limited experimental dataset, and durability tests such as freeze-thaw or long-term shrinkage will not be conducted in this study. Despite these limitations, the study will provide valuable insight with strong practical implication. Thank you very much for your attention. I am happy to answer any question. Thank you.